Okay, so today we are going to look at something. This is kind of like yes, sir.
It says consider the following.
Where's my picture? Do you guys not have a picture? Nope. I have a beautiful picture.
I know.
That's okay.
I got a picture. It's just one line down the middle.
That's on the back. Oh, well, we'll draw it on together. I mean, not me. I already have it beautifully there. But you guys can draw it.
But we're not in 19, whatever.
Yeah, you'll be all right. So, see, this is what I'm talking about. Technology fails. You still got to know how to fly the plane. So, that's really frustrating. Oh, such is life. Okay, so listen up. The topic we're covering in math today, in my mind, is kind of a ceremonial one. It's kind of a weird one. We're going to learn about lines in standard form. And I think of it this way. Has anyone ever seen footage of like Buckingham Palace on TV? What's Buckingham Palace? Yeah. That's where the Queen lives. Yeah, when she's in London, the Queen lives at Buckingham Palace. And if you go to London, you can walk down the mall. If you're currently on your phone, could you put it away from me, please? Thank you very much. Maddie, we're going to have a fist fight at some point today. Okay, so anyway, if you walk down the mall, you can go to Buckingham Palace. And outside Buckingham Palace, they have what? Yeah, the guards. Has everyone seen these guards before? They wear like red coats and they got the big poofy hats and they march. Now, I want to be clear about something. First of all, that looks like an exhausting outfit to have to wear all day, and I wouldn't want to have to do that.
I would.
Especially in the summer, but that big furry hat does not look nice for summertime wearing. But the funny thing is when you go there, you have these ceremonial guards who march and entertain the tourists. But then at like each corner, there's just like a guy wearing like Green Army fatigues with a submachine gun, and he's like pointing it at the crowd. And those are the guys who are really kind of more doing security. You know what I mean? That's kind of what today's like. We're going to learn about another form of a line that is, it's going to utilize some of your algebraic skills to get out of it, but it's not a very useful way to express. Despite that, it's called standard form. Now, let me ask you, Cassie Sparks, because you are through grade 12 math at this point. Have you ever made use of a line in standard form where ax plus by plus c equals 0? No, never in your life. And nor will you. But here's the thing. Here's the thing. Sometimes this will be the output that you get. It could be that a piece of software gives you an equation in this form. You're going to have to know how to deal with it. We give an example later on of like a company that does a pricing index based on an equation like this. And that comes up. Sometimes in finance, they use equations like this. So what we're going to look at today is what does this form of an equation for a line look like? And given this form, how can we turn it into a form that's more comfortable for us, one that we can use? And we're going to turn this into slope-intercept form, y equals mx plus b, which is the form we've been using so far, because we're getting comfortable with that. We know what m means. We know how to use it. We know what b means. We know how to use it. So that's how we want to deal with these if we can. So I want you to consider the following. Now, I understand that apparently you have just a big blank space here. Sorry about that, but we're going to copy down this table of values. We are working with this equation. 3x minus 4y plus 8 equals 0. So I want you to copy that down. Copy this table down. Go ahead, it's not a big one, mercifully. Yeah, don't worry about how it says f at x. You can just call that y. If you put f at x, not the end of the world. You're just jumping ahead to some grade 11 math. Function notation? Oh, no. Once you...
what was the word why?
Yeah, I think they're both useful. But function notation is lovely. Function notation is very nice.
I'm scared.
No. Don't be scared. Don't be nervous.
You're just jumping into grade 11.
Americano? Is that an Americano?
Yeah,
Okay, so what I'd like to do, listen, look at me. Look at me. This equation is what we call in standard form. Instead of how we normally write it, which would be y equals 4x plus 2 or something like that, where we have solved the equation for y, in standard form, we move everything to the left side of the equation, and the only thing we leave on the right side of the equation is 0. We leave absolutely nothing on the right side of the equation. And of course, the number that means absolutely nothing, 0. So we move everything to the left, we let the right side equal 0. When you get in grade 10 to other types of equations, things like parabolas and other more advanced functions, this equation actually starts to make a lot of sense. There's a lot of good reasons to use this kind of form. But in this grade level, it's not quite as logical. It's not one that's comfortable for us, but it is what they call standard form. And you do come across equations written in this form, where we move everything to the left and we set it equal to 0. Yes?
I'm sorry, why is there like a negative sign in it?
That's part 1.
Oh.
Oh, sorry, part 2. Part 1 was housekeeping. Part 2 is this. Roman numerals. Okay.
And dash just like.
Yeah, just dash. Just saying this is what we're looking at. So in this form, I've given you a table of values of numbers that satisfy this equation. So let's go ahead and plot them. And you're going to have to quickly sketch this graph. Sketch is all you need to do. You do not. Honestly, here you go. -1, -2, 1, 2, 1, 2, 3, 4, sketched. We're just sketching. Okay. So at -2, what is the value of y? No. 0.5, good. At -1, what's the value? Yeah, 1.25, which would land right there. What about at 0? 2. And what about at 1? 2.75 will put me right there. And what about at 2? 3.5. Okay. And there we are. So I hope the first thing you'll see, oh, that was unfortunate.
Oh, that
There we go. Again, you're just sketching. It's okay for you to know. I hope you'll see, looking at my graph right here, this equation, does it make a straight line?
Yes.
Yeah,
Mine doesn't.
that's okay.
Mine makes a curvy. Oh.
Okay, so as you can see, if I take this equation and I'm able to find x and y values that satisfy this equation, it makes a straight line. Here's my question. Here's my question. What would I have to do to get x and y values that satisfy that equation? Can I show you? You don't have to write this. In fact, I'd prefer that you not write this. But, shh, quiet. And the graph will come back, so be calm. But I want to show you this. If I wanted to ask, put away, I'll take it. If I wanted to find what the value of y was when x equals 3, what would I have to do?
Oh, what the y
Very good. So I would say 3, and then instead of x, I'm going to put the number 3 minus 4y plus 8 equals 0. That's my equation. What would I have to do now?
And then you would just use the like the stuff that we did for work. So you have
Sure. So 3 times 3 is,
9.
whoa. That's right. 9 minus 4y plus 8 equals 0. Can I collect like terms here?
Yep, 9 on 3.
Sure. So negative 4y equals 9 and 8 is what, 17? Oh, I shouldn't have done that yet. I meant to put plus. And then I'd have to subtract 17, right? Negative 4y equals negative 17. And then I'd have to divide both sides by negative 4, right? I get 17 over 4, which is what? Yeah, 4.25. Okay. And then I would know that my point was 3, comma 4.25. Again, you do not need to write this. You don't need to follow down. Let me ask you this. Is it going to make for quick graphing if I have to do that to get the coordinates of every single point? Oh, dear God, no. Right? That's going to be a lot of work. Now, admittedly, how many points do we need to make a line? Just 2. So I'd only have to do that twice, but still, this is quite a bit of work, isn't it?
Yes.
Okay. So, and I would have to do that work at a bare minimum twice to get the equation for my line, or to get just the coordinates of my line and put it on a graph. So what I want to work with is converting this to slope-intercept form. We can make this equation, ax plus by plus c equals 0, look like this equation, y equals mx plus b. And once we do that, it's something we know how to work with. So let's all flip onto the other side.
Oh, x is here, and then we do x is at 3, right?
Okay. So right now, this equation is in what we call standard form. Some number times x plus some number times y plus some number is equal to 0. That is what we call standard form. We want to convert it into slope-intercept form. Hey, why do we call this slope-intercept form? What do these letters stand for? Yeah?
M is slope, x is x, and b is y intercept.
Very good. That's slope. That's the y-intercept. And you're right, x and y remain x and y. We would think of this as the output. It's the number we're going to get as our answer when we use the equation, and we'd think of this as our input. Yes?
I'm sorry, is it fast way to write y intercept? It's so wrong.
Yeah, B.
I mean,
I'm not being snarky. Like, that's why we use the letter B, because the word y-intercept is long. Sometimes you'll see people put like y-int. I kind of think that's lazy. Yeah. I put B, or I put y-intercept. But if you put like if you put like this, I certainly wouldn't care. That's fine. There you go.
How does a B stand for the Y intercept?
You know, that was a great question. That is like one of those who broke up the Beatles or what's the meaning of life kind of questions. I just don't have a good answer. Why is this guy? I know that one, but okay. So I'll tell you all about it later. So here's the thing. In slope interform sept, in slope interform sept, and that makes a lot of sense. In slope intercept form, in y equals mx plus b, what have we solved this equation for?
slope.
No, not slope. What have we solved it for? What equals something? What is by itself? What have we isolated?
Output y.
Y. We've isolated y. The trick to this equation is we've made it that only the y is on the left side and everything else is on the right side. So that's what we're going to do down here. we are going to isolate y on the left side. Then we're going to tell y that it's not welcome on the right side of the equation. And that, yeah, no, that's what we're going to do. Hello, Miss Farmer. How are you?
Oh, are you doing algebra?
We are.
I love algebra.
See?
Why?
See?
You know, I start my morning with coffee and a cigarette. I just like
That's a knee slapper right there. So
5x plus y plus 2 equals 0. So when you cross the bridge.
Okay, so as we have kindly had pointing out to us, we are trying to bully y here. We're trying to isolate it. We're trying to leave it all by its lonesome on the left.
But why?
So, in this nice simple case, if we are trying to get y by itself, what is going to have to leave it? What are we going to have to get rid of?
5x plus 2 is going to go to the other side.
Okay, good. And just for the sake of clarity, I'm going to do them one at a time. In practice, I would not do them one at a time. I'd do them both at the same time. But let's just take our time here. First, we want to get rid of all the x's. So I would subtract 5x from this side. And if I subtract 5x from one side, that's right. What would my next line be then, madam? Sure. What's left over here? Very good. And on the other side? -5? Beautiful. Well done. Good. So we're getting closer. Is y by itself yet? No. So what should I move next? Yeah, and how do I get rid of it? I'm subtracting 2 because that's the opposite of adding 2. If I do it to the left side, I have to do it to the other side. Mr. Bears, what's my next line going to be? Yep. Negative what? Oh, are these like terms? Negative, the 5x is still there. And now we have, yeah, very good. And those aren't like terms, so I can't do anything with them. They just stay like that. And that's okay. That's okay. That's okay. So here we are. Now, now that we've done that, we can now describe our line in a way we couldn't before. When I looked at the original line, it didn't give me any information. Now, I want you to tell me the slope of this line and the y-intercept of this line. I want to know the slope and the y-intercept of this line. Good enough. Well, from the previous page, what is the m in y equals mx plus b? Slope. What is the b in y equals mx plus b? You got it. So let's look here. What is the slope? -5. Shh. Hey, is this a line that goes up or a line that goes down? Down. Is it a steep incline down or a shallow incline down? Would I want to put my great-grandmother Pearl, lovely lady, would I want to put great-granny Pearl in her wheelchair at the top of this ramp and let go? What is wrong with you people? Good God, man. What do you think I'm trying to do to poor Granny? She's 102. Yes. She is 102 years old. Hey, okay. So let me ask you this. Hey, if I were trying to, I mean, normally I would wheel her down, but let's say we wanted to make a ramp that Granny could go down herself. What kind of slope would I want it to be? Negative, because we're going down, yeah?
Negative 0.00001.
Yeah, a small number. As a fraction, it might look like what? Yeah, maybe 1/8. 1 foot of drop for every 8 feet of run. That's the kind of slope we want to put Granny on. That's more, maybe 1/12. I don't know. Like, she's pretty frail at this point.
Yeah,
I mean,
all the way, like, Cheeto
to be
Burger.
clear, she's the meanest woman I've ever met in my life. I
Then
think
why do you care if it's steep or not?
because I love her, because she's my great grandmother. But I think they made people a little tougher in like the early 20th century. I will never forget, we were visiting her once, and she's kind of slipped quite a bit. But my grandparents from my other side, so not related to her, my mom's parents were in with us for a visit, and my grandfather went over and said, "Hi, Pearl, I don't know if you remember me. My name's John, but I'm Joe's grandfather, and we thought we'd come say hello." And she said, "Of course I remember you. Nobody forgets the nightmares." We're good. Anyway, so Granny Pearl, she's tough, but not as mobile as she used to be. Okay, what's the y-intercept here? -2, good. There's also a great story. I shouldn't. I'm not going to.
Oh, no, you do it. Yeah, now you're definitely have to. Great story.
Okay, so
Thank you.
the other thing about Pearl is she really likes her brandy. And so we'll have her over for Christmas dinner, and there'll be like 20 or 30 people there. And she'll keep saying to everyone, like, "Oh, I haven't had a glass of brandy yet. Could you get me one?" And then it's a liquor. And she'll quickly drink this and then hide the glass and then go and ask somebody else. So she has a real habit of getting rather drunk at family events, which is embarrassing when you're returning a 102-year-old lady who is drunk to her old age home. So this happened about 4 years ago. And so we were trying to kind of like sneak her in and just keep her quiet. So as we were coming in, somebody was going out on a stretcher. And Granny said, and this is true, "I hope that's Alice. Her room has a better view than mine."
Oh my God.
That's my great grandma.
I feel mildly. It smells like the school's burning.
Yeah, no. We're gonna die. Call the fire alarm.
Out through the window.
Please.
I got nothing. Okay. Shh. I want to try the same thing with this one. To put this in slope-intercept form, what are we trying to do?
Isolate y.
Isolate y. So we have got
Is Y crazy enough?
3x minus 4y plus 8 equals 0. To isolate y, what should I do first? Okay. Sure, how am I going to do that? Subtract 3x. Subtract 3x. Okay, shh, guys. What does that leave me with on this side? What does that leave me with over here?
4y minus negative 4i plus 8.
Equals? Okay, good. What next?
Subtract negative 8 from both sides.
Subtract 8 from both sides like that? Okay, what's that going to leave me with?
Negative 4y equals negative 3x.
Okay, now, shh. We want to be careful with this next one. Shh. We want to be careful with this next one. What's the next step we have to do? What do I have to do now?
Both sides are -4.
Okay, now listen. Shh. We're going to divide by -4, but this is what you have to remember. Multiplication and division are distributed. Shh. This is key. If you get this wrong, you'll make a lot of mistakes. Multiplication and division are distributive. Remember that? Just going to show you a sidebar here. If we're multiplying 3 by negative 3x minus 8, if we were multiplying, I would have to do what with that 3? Yep. Very good. It would get multiplied by both terms. Does that make sense? If that's true of multiplication, it's also going to be true of division, which means that every term on the right side is going to be divided by -4. How many terms are on the right side? 2 of them. I have negative 3x and negative 8. They both have to be divided by 4. That's key. Very important. So negative 3x gets divided by -4. -8 gets divided by -4. You have to remember that. Where there is addition and subtraction, we have to distribute multiplication or division. It's called the distributive property. With multiplication, that's often intuitive for us. With division, we tend to forget. So now, -4 divided by -4, what's that give us?
Y.
Just y. What is -3 divided by -4?
3 over 4x.
Yeah, 3/4. You could put the x on top with the 3, but why not make it fit the form mx plus b? This is more comfortable for us. So 3/4 x. And then what's -8 divided by -4?
Plus 2.
Plus 2. Very good. So we have to remember division is distributive. It gets distributed.
I think just the division sign over right.
Yeah, if you wanted to, like, had you wanted to, maybe I'll copy and paste it. There's no way that was quicker than just rewriting it, but that's okay. That was, oh, this is so unhelpful.
Oh, God.
But now I'm committed. Okay, if you had wanted to say that, hey, we're going to divide this side by 4, and then kind of put brackets here and say divide this side by 4, and then kind of draw the arrows to distribute that in, sure.
Can we just like put it underneath? We just make one big sign.
Here's the deal. Can you do this? That is 100% accurate, but this is where people screw up. And they tend to say, okay, that's -3x minus 2, and then just leave it. You can do that. You just have to remember that gets done to both of them. As long as you can remember that, that works. For my way of thinking, Ethan, could you please stop that? Thank you. I appreciate that. For my way of thinking, I am less likely to screw it up if I do this. But, as always, there's a million ways to do a math question. And as long as you obey the only rule that matters in algebra, which is that whatever you do to one side, you must do to the other, you won't be wrong. So, whatever works for you. And in this case, what's the slope? 3/4. And what is the y-intercept? This is just for you. I felt lazy doing it. There you go. I'm sorry. Okay. Again, why do we do this if the fact of the matter is I can go into Desmos and type a line in standard form. If you're wondering, this is the international symbol of typing into Desmos. Why bother doing this if Desmos can graph a line in standard form? No, Desmos is like your best friend.
I was going to say it's just an annual nightmare if it doesn't work.
Sure, true, fair enough. But the other thing I'd say is that, absolutely true. The thing I'd say is this. We understand what the numbers mean in y equals mx plus b in slope-intercept form. We know that m is the rate of change, it's the slope. We have a concept of what a rate of change means. We know that b is the y-intercept, the starting value, how much you start off with. We know what that means. We can make use of those. So I want to do a last example. And this is stolen from the textbook. This is not my example. Thief. The word you're looking for is thief. Good artists borrow, great artists steal. You're not a plagiarist if you cite your work, and I'm citing it here and live for all to hear in front of you. This is the property of McGraw-Hill. Whoever wrote that. Timmy McGraw and Jimmy Hill. All right, this is the work. So, well, look at this. There's a banquet hall that uses the equation 25n minus c plus 1250 equals 0 to determine the cost of the hall rental c as a function of how many people come, n. Okay. Is this a good equation?
Nope.
Oh my God, no. Again, it's one of these ones that doesn't tell us anything. It's in standard form. So here's what I want. Shh. I want you to give me a version of. I want you to give me a version of this equation where the cost relates to the number of people who come. So I want you to solve this in slope-intercept. Use your algebra skills to put this in the form C equals blank n plus blank. Only don't put blanks there. Put numbers there. All right, get on. It does a lovely job, right? It really does. Let's see some algebra here. I got algebraically manipulating. Yes.
That's it, moment now.
You're so cheating with it.
Unless it's the actual Earth mass. But Earth. Okay, come on, let's solve them. That's an easy one. I can do these ones. First we work
Yeah, but they still are right.
And then I told you at the bottom, what are you trying to get all by itself on the left?
Yeah,
See,
they all
good.
and the only
So I take the equation and then manipulate it to see all by itself on the left.
I don't remember.
And so.
That's your one.
Maybe it's-
Sorry, everyone memorized
Yeah, so what do you have to divide by? Negative, not C, that'll get rid of C. Negative 1, good.
You gotta multiply by -1.
That's right. Actually divide by -1, but in this case it is the same thing.
Oh my God.
How we doing?
Not very good.
Okay, so let's start by writing the equation then. Just put these here.
And 9.
What's under equation? 25 with 25 10 minus C. That's the standard form. We want to isolate what? 12
Yeah,
blocks.
they hide it down.
Let's see, that's
Okay.
lost.
We want it to see by itself. What are you going to do for see all by itself.
Yeah, how to multiply Yeah.
How do you put the opposite pattern by itself?
Especially if you have that much. I mean, we're especially.
First, start. Oh, yeah.
I will see that. I just saw it link up. Yeah, it doesn't actually work.
Sounds like. That's okay.
That's it. No.
Yeah, that's don't worry.
First of all, you're right.
You want to see it.
I'm just waiting to come back. No, it's the same.
You did good, but you can't see together. This line is good. This line is good. So 25n minus 12. 25n minus 12. Does it make sense? So
Yeah, subtract 12 from this, subtract 12 from this.
Oh, you might take.
What did I say? It's like, subtract 12. And negative that makes sense? Yeah, it's the lobby. It's just. Easy to like that. Easy to say.
I get confused too sometimes.
What? Doesn't even benefit. I do what?
Care about my hand.
No, I don't. Okay, anyways.
Okay. Let's take it up to group then. Okay.
I'd like to take this up together as a group if we can. Can I have everyone's attention up here? Shh. This will be the last 2 minutes of like me talky time. That'll be you worky time, but up here. So we said this equation is 25 times the number of people minus the cost plus 1,250 is equal to 0. That is a terrible equation. I want to isolate C on the left. What do I have to move first? Yes, ma'am. Very good. And how do I get rid of it? Very good. Maddie. Sparks. Gentlemen. Okay. So what remains on the left side once I've done this? Yes, ma'am. Very good. That's perfect. Ooh, I didn't line my equal signs up. It's stressing me out. That's better. It's still not perfect, but it's better. Okay, what shall I do next? Yes, sir. Very good. Subtract 1,250 from each side. Now, that should leave me with negative C equals negative 1275N, correct? Why not? Because that's my instinct too. What do we have to remember? This is everyone's instinct, natural. What do I have to remember? Yeah, they're not like terms, so I can't combine them. But again, if that's your instinct, you're thinking right. You want to simplify things. You just have to be careful you don't do something against the rules. Because we're not rule followers, but once in a while. So should I have this instead? That looks good. Now, this is almost a perfect equation. What don't I like about it? Yeah, so how do I get rid of it? It's really negative 1 times C. So what should I divide it by? Yeah, I'm going to divide it by negative 1. And if I divide it by negative 1, I have to divide this by negative 1. And that one by negative 1 because division is distributive. It applies to everything, every term. And that would leave me with C equals... Okay, that is great. Good job. Now, let me ask you. Yes, what she said. Let me ask you now. How much does it cost to rent this hall just as a flat rate? Good. So the flat fee is $12.50. That's what you pay no matter what. What's it cost per person? Yeah, it costs $25 a person. Good. Well done. I would like you to do that homework right there. I think I actually printed that on your sheet today because I was feeling organized. forget it. She just didn't print. I'm not quite sure why. I think so. Let's see if I can print on the next. Yeah, so get some time working on that homework. We'll take it up tomorrow. Right, Tom? I will get you in the day. I might have already said. If I don't, I will get you in the day.
I can only do it because
Either one of you that's going to do this.
You might not get all done. Yes. Of course. Okay, everyone should have the notebooks out. They should be working away on this.
Big Orlando?
This one.
Want some paper?
Yes.
So I'm just gonna half of it.
I'll go back to the left. This part's- the other.
Yes.
Yes, this part's
I know
the-
what you do. I don't care.
Whoa. Calm down for a second. Do your roll.
oh, sorry guys. You should have just gave
Yeah, I'm not sure. You should do that. You want to go back on?
Okay.
Get it up, Roger. Get it work.
No, you don't need I love that.
Maddie.
I was, I've only had your textbook in copy twice.
All right. I have breakfast. You put some That's a really tough one.
They're on the wrong page.
Nathan, where's your textbook? Thanks, sir.
not watching the fruit video. It's a fruit video. I'm no one.
Ms. Sparks, do you mind putting the lights up?